Before we go into this aspect, let's look at load transfer. We have not talked about how the vertical load transfer takes place in a tire, right? Okay. All of you drive bicycles. Okay, let us first understand how actually the bicycle wheel carries the load. Oh, you see that every day. It looks like it's very simple. What is there? You would say that, okay, that's the bicycle wheel. I'm just putting the spokes, okay, on the wheel. What's there? There's going to be a load like this. There's going to be a load like that, and it's all over. That's the free body diagram, okay, and the wheel is under equilibrium. What else is there to talk about this? Unfortunately, a lot more, because the spokes, as you know, is a very thin piece of steel. Okay, if you subject that spoke to compression, what is that's going to take place? It's going to buckle. So the spokes are assembled with tension. Okay, they're going to be actually assembled with tension, right? So when the spokes are not, let's say that they are not on the ground, just take the wheel out, then there's a tension in the spokes which are opposite to each other, and they would cancel each other. Okay, so it's not that the wheel will run away in one direction or the other. They are under equilibrium because of the forces that are inbuilt into these spokes. Clear? Okay. Let's just consider a very simple situation. Forget about all other spokes. Now, this spokes is under tension. Just we'll consider one for clarity. That spokes is on the ground. So there is a compression onto the spokes. So what really happens is that the tension here is reduced. Okay, the tension here is reduced. Let's depict that with an arrow. Okay, that is all is the tension. But this guy who is sitting there at the top, his tension is not reduced. So his tension is high. With the result, if you look at the forces, okay, which are actually acting on the axle, you would notice that this guy is the one actually which is responsible for the support of the wheel. In other words, the wheel hangs from the top, and that's not just pushed from the bottom. So the hanging here, this hanging here is one which holds it, So there are a number of forces. That's the load that's acting, and there is a spokes which has an initial tension. It's a ground. So the equilibrium demands that the whole wheel hangs the axle from the top. This is exactly what happens in a tire. But who plays the role of the spokes in a tire? It is the sidewall of the tire. So let's draw the sidewall. Okay, let's say that that's the sidewall of the tire. Okay, they are, let's say, sitting in a rim. All of you have seen a rim. Okay, and then again it goes like that, and then that's the rim, and then there is a sidewall of the tire. In other words, let's say that that's the tire, and that's the bead, what is called as the bead. Okay, you would have seen that, all those things, and that is this is the tire. Right. Now, this side wall is now going to act like a spokes. Here the tension is in the spokes is given when we assemble the wheel. Here the side wall gets the tension from the pneumatic pressure. Okay. So, the pneumatic pressure, in other words the inflation pressure, you go to a shop and you fill it up, 32 psi is the pressure you say you keep it. So, that pressure is what gives the equivalent tension in a spokes to the side wall, right. So, is it clear? That gives the tension. Now, let us see what happens. Okay, that is the axle. Let us look at what happens to this whole situation. Of course, the first thing you would say that, look, that is the inflation pressure, that is how it acts throughout. Okay. There is an inflation pressure like this, okay, acts on the rim. Let us say that it is a tubeless tire, if tube tire does not make any difference. That is what is the inflation pressure, and that is the ground reaction. Clear? This is how it acts. The first thing you have to understand is that the load bearing has nothing to do with the compression of the air inside. In fact, this issue was settled long ago in the early 60s. If I remember right, there's a paper in 1962 which very clearly showed that the pressure, the pneumatic pressure, does not vary more than 1%. It's much less than 1%. So it is not that this air, okay, carries the load, right. Air of course acts as a cushion. They are the different thing. This gives that springiness and so on. So it is not that which carries the pressure. Then what is that which carries the pressure? In the same fashion as we explained the spokes, okay, if you now look at the side of the tire, pardon me that it's not a very good circle. Now, inflation pressure acting all through, this pressure, now this, so that's how it acts on the ground, right. This there's a difference between in the tension, again the same fashion here. So that now reduces, on the other hand this pressure gives more, or this is more than this now, and so the side walls have the tension, okay, to pull the rim, and through which it pulls or gives the reaction to the axle. So in other words, the vehicle load is reacted upon by an upward force, the downward vehicle load, reacted upon by the upward force which comes from the top. Again, as in your bicycle wheel, a passenger car tire or a truck tire or whatever it is actually hanged from the top. It's hanged from the top. It is not that they are supported from the bottom. So the whole load actually goes through this side wall onto this most important component called the bead, okay, which transmits it to the rim, and that gives the force for the rim to support the load. Is that clear? Any questions? Okay. So this is an important concept on how load is transferred or held by the tire. Okay. We will come back to this rolling tire again. This is a phenomenal concept of pneumatic tire, because as it rolls, the whole load, you know, the different points in the tire is now held by different parts of the tire, because this is not a stationary, this is a stationary figure, but imagine that actually it is rolling. Okay, as it rolls, so there are different parts which come and which is under tension and which holds the wheel. So there is a compression tension or a cycle which takes place, which is also responsible for hysteresis. Now let us come back to this figure